In this lesson, we are going to determine a differential equation from a general solution. Hello and welcome to my channel. I'm Mensa Augustine. Please kindly like my videos, subscribe to my channel, hit the notification bell to get notified when I upload new videos, comment and share for us to build the mathematics community. We have y times sin x minus x times y squared equals c. We have to show that this function or this equation is a solution to the differential equation y into cosine of x minus y dx plus into bracket sin x minus 2xy dx equals 0. So now let's see how we do this. We are just going to use the implicit differentiation, but remember that y prime equals dy dx and y prime prime equals d squared y on the x squared. Since here we are going to differentiate implicitly with respect to x. If you differentiate y with respect to x, we get dy dx and then multiply it by sin x. Now, if we differentiate sin x, we get cosine of x and then multiply it by y. That is, we have used the product rule there. X times y squared, let's use the product rule. If we differentiate x, you get 1 times y gives y squared. If we differentiate y squared with respect to x, we are going to get 2y times dy dx. Then we multiply it by the x to get negative 2xy dy dx. That is very simple as that. Now c is a constant. If we differentiate, we get 0. So we have dy dx here and we have dy dx here. So we are going to factorize it out to get sin x minus 2xy times dy dx. Here we have y here and we have y squared. So we can factorize y out to get y into cosine of x minus y equals 0. We then multiply through by the x to clear the denominator, which is the x. So this gives sin x minus 2xy dy equals y into bracket cosine of x minus y, bracket close, times the x equals 0, because the x times 0 gives 0. So this shows that y sine of x minus x y squared equals c is a solution to the differential equation underlined. Next, we show that x squared y equals 1 plus cx is a solution to the differential equation into bracket x squared y plus 1 dx plus x cube dy equals 0. So here we use implicit differentiation. If we differentiate x squared, we get 2x times y gives 2xy. If we differentiate y, we get dy dx. Then we multiply it by x squared to get x squared dy dx. Remember, we use the product rule. So here, if we differentiate 1 is 0. If we differentiate cx with respect to x, we get c as a constant. Now, we have c here to substitute. So we make c the subject from the original equation. Or we can multiply through by x to make this one become cx. And then we have 2x squared y plus x cube dy dx equals cx. Now cx can be found in the original equation. So we just take 1 and subtract it from x squared y to get the cx. So we have 2x squared y plus x cube dy dx equals x squared y minus 1. So now we've substituted the cx. Very simple. Or you can make c the subject and then do your substitution. Anyway, it's good for you to go, but you need to be smart. Now, here, if I take x squared y from 2x squared y, I'll get x squared y. And then bring 1 here to become plus. Then plus x cube dy dx equals 0. And multiply through by the x to get x squared y plus 1 times dx plus x cube dy equals 0. Let me place more emphasis on my substitution here. Here, I said that I multiply through by x to get cx because I know that I have cx there. But if you don't want to follow my procedure, you can make c the subject and then substitute for only the c, and it will give you the same answer. Our next question is to show that cy squared equals x squared plus y is a solution to the differential equation 2xy dx minus into bracket y plus 2x squared bracket close dy equals 0. So join me as we do this step by step. Now let's see. If I write the equation cy squared equals x squared plus y and differentiate it implicitly with respect to x, then if we differentiate y, you get 2y times dy dx, and then you multiply it by c to get 2cy dy dx. If we differentiate x squared with respect to x, we get 2x, and if we differentiate y with respect to x, we get dy dx. Now, what can we do? We can make c the subject in the original equation and substitute here, or we can multiply each term by y. Do you know why? The reason is that if I multiply each term by y, I'm going to get cy squared. Have you seen that? I've got 2cy squared. Very simple as that. Yeah, here I multiply this one by y. So we don't multiply the y by the dy. Yes, here we see that I have cy squared, and here I have cy squared. So here 2 into cy squared is x squared plus y. You can be using these tricks and it will help you always to move faster. Very simple. So the next thing is to expand what we have. So we have 2x squared plus 2y all times dy dx equals 2xy plus y times dy dx. Now, what can we do? Let us proceed by multiplying through by dx. We are going to get into bracket 2x squared plus 2y times dy, because the x will cancel dx, equals 2xy times the x plus y dy. Now, we have dy here and we have dy here. So let's group them into 2x squared plus 2y. Then this will become minus y. And then we factorize the dy out. Equals 2xy dx. Wow. Grouping them on the left hand side, we have 2x squared plus y dy minus 2xy dx equals 0. We can also group them on the right hand side. We have cy squared equals x squared plus y is a solution to this differential equation. Thank you for watching. Please like, share, comment, subscribe, and let's build the mathematics community.